Welcome to my presentation on photocathodes for solar-driven water splitting. Climate change is a major global challenge. As of 2024, studies show that the global mean temperature was around 1.55 degrees Celsius above pre-industrial levels, which is mostly due to carbon emissions. Over 91% of CO2 emissions come from the combustion of fossil fuels, which we use for energy. The reliance of fossil fuels for energy contributes to greenhouse gas emissions and air pollution. Sustainable energy solutions are essential to mitigate climate change and meet the growing global energy demand. So how does this process work, and what is the role of the photocathode? In this setup, the first step is that the semiconductor in the photocathode absorbs sunlight, leading it to capture photons, which are particles of sunlight that carry energy. When they hit the semiconductor, they excite electrons and give the energy they need for the process. Then, excited electrons move through the semiconductor to the surface. Step 3 is where the electrons reduce hydrogen ions in water to form hydrogen gas at the photocathode. This is the half equation, and hydrogen bubbles form. This hydrogen gas is what is used for clean fuel. Water is oxidized to release oxygen gas at the photoanode, completing the water splitting reaction. What are some commonly used materials for the photocathode? Well, one of them is copper oxide, as it strongly absorbs visible light. It has positive charge carriers and it is low cost. However, it corrodes easily, so it loses stability over time. This can be fixed by adding protective coatings like titanium oxide. Another one is P-type silicon, which can also be used as a very efficient light absorber. However, it's not stable in water and corrodes easily, meaning it also needs protective coatings. Gallium indium phosphide can also be used, as it absorbs sunlight extremely well. However, it is expensive and complex to make. This links to the grand challenge of providing access to clean energy, as solar-driven water splitting uses sunlight to produce hydrogen fuel without carbon emissions. It also supports the UN goals for clean energy and climate action, moving us closer to a sustainable future. In conclusion, photocathodes are essential components in the process of solar-driven water splitting, providing a pathway to generate clean hydrogen fuel. Their development is crucial for addressing the global energy crisis.